Mic on? Okay, yeah. Hi everyone, I'm Takan Abraham from the Eagle. Today I'm going to talk about the using DPDK with a Go. We've been working with developing the software switch in previous project using DPDK, which was called Logopus, which was sponsored by the NTT. And in this project we use the DPDK and the rail socket, everything written in C. After we released this Logopus, internally with NTT we had a discussion, and after considering the extensibility, expanding more the feature, adding more feature in the Logopus, we decided to use first the DPDK only, no support for the raw socket, and plus we wanted to make use of the Go to write the core part of the router. So actually the goal of the Logopus 2 was still getting a good performance, but at the same time we wanted to have maintainability and extensibility. So this was the rationale why we have chosen DPDK plus C for the performance, but for the maintainability and extensibility we decided to use a Go. What is Go, by the way? It's many people may know about it, but it's quite simple. The open source program language, mostly driven by Google. It has a very strong type system, and the type is statistically static, but at the same time it has some sort of flexibility. It's quite interesting though. And by the design, it has a concurrency support natively in the language. It's built into the language. And there's a garbage collection, and it's still the compiled language. And you can use the C libraries directly from the Go. Of course, via the C Go, but it's kind of direct. You can directly call the C library. So if we compare the Go and C, the complexity, it's simple by design, the Go is. But the C, of course, we all know C, so we are familiar, we've grown up with C, so we are more familiar with the C, but could become complex easily. But the performance, unfortunately, Go is not that good as C, so you don't want to use Go where you really need the performance. But it has because it's compiled language, you have a moderate performance even with a Go. And the concurrency memory management was quite simple in Go. It's the built-in and language. And finally, interestingly, the Go itself has a build system. So if you just type Go build or Go install, whatever, you just build the Go, the whole package, and you don't have to worry about the configure or the make files or whatsoever, the configuration. Everything is automated. So it's quite simple. Though it sometimes causes a problem, but yeah. Now, so to achieve the performance, we definitely wanted to make the data plane run fast as possible. And for the control plane, of course, it could be fast, but we can live with even though a little slow, it could be okay. But we do not want to disturb the data plane, the processing of data plane, by managing the packet processing. So finally, at the end, we decided to write everything in C plus DPDK where we really need the performance, but the code must be as minimum as possible. And so that C part focuses on the packet processing only. So they don't have to worry about getting the configurations from the server or what's the respond to the CLI or whatsoever. No need, just focus on the packet processing. And everything that's complicated, like the MAC table management or the routing, everything goes to the Go part. So the really focusing on the packet processing. And but at the same time, we have to make the C and Go to communicate to each other. So for that, we decided to use a DPDK ring for this communication and make the lock-free where possible. And so I think we managed to do this by using making the gold feature, the ring, and the older DPDK feature. Yeah. And from the maintainability and extensibility perspective, we want to make the code as simple as possible. So although we want to do everything that requires performance C, but we tried as much as we can in Go. So, for instance, the setting up the ring, setting up the etherdev, or the setting up the mempool, the initializing EAL, everything is done via the Go. And once everything is set up, we let the C part to run as fast as possible on the slave core. And also, to make the code simple, we wanted to make use of the Go language features as much as possible. So we use this bunch of slides, map, whatever we can use from the Go. And of course, we definitely still need to use the DPDK where we need to interact with the C part. So this is the brief architecture, the diagram, how we designed this new software router. So the blue boxes are written in Go. The orange boxes is written in C, and the green boxes is a physical core. One thing we have to be aware of is that the Go automatic is because the concurrency is built in the language, so it kind of has a virtual machine inside. And when they need a concurrency, it automatically spawns a thread and internally create the kernel thread and run the code in parallel. But because of that, we definitely wanted to make sure that the core we want to use with the DPDK be isolated from the OS. So we have to specify the ISO CPU, but at the same time, we have to make sure that in this design, we decided that the master core still doesn't need to be fast, and because we do most of the part in the Go. So the master core share the core with the Go, but the rest of the slave core, we definitely want to isolate from the slave. So you have to have in mind that how the Go user makes use of CPU core and how you make better use of the spreading use Go, the core. But it's going to be complicated when we start using service core, but that's another story, I guess. So for each module, the router or the bridge, the main module is written in Go, but it has the minions in running on the slave core do all the packet processing. So for this, where the module that requires the performance, the management control is done in Go, and just packet processing is done in C. Each module had an input ring, get the pack and buffs, and do whatever they need to do, and pass it to the next module where it's been specified. But we have some interesting module like the tap or the host interface. Those are specifically used to process the VRRP or the ARP ICMP. So when we rather doing all the ICMP ARP processing internally, we just wanted to hand it over to the kernel to do it by creating the tap and then just for the packets where needed. So for those, because we don't need a real performance for those, so we written everything in Go. So this, by design, you can choose whatever you want to do, but you have the flexibility to choose. Now, main topic. So in order to do this new Lagopos 2 implementation, we needed to have the binding. Of course, we looked at the many DPDK bindings to Go. There are a couple of them in the GitHub if you just search for them. But when we looked at them, we saw our a little of the drawbacks in there. When we want to use a Go, we definitely want to have the type safety, the simplicity, and the performance, but some of them was just a simple direct mapping of the Go to the C to Go. So all the DPDK API was directly mapped to the Go function, which we believe is not that fancy, unfortunately. So for instance, DPDK API, of course, because it's C library, so make use of a lot of the generic types, uint, or unsigned int, uint8, t. But for the Go, if you want to use it for the Go, we definitely want to make sure that that uint8 t, for instance, being used for the port ID, is actually the port ID, not the random uint8 value. So maybe it's a little small, but so what we did is that we definitely wanted to wrap the port ID. Okay. The port ID, for instance, we defined the Go-friendly type, and we wrap it with the Go type, and then when we call the C API, the DPDK API, we convert the type and do it, etc. And when calling def info, so we definitely want to make sure that we are passing the correct port ID. We take we define as the method function, not the generic function, but the method, so that we are sure that this function is called on this correct on the object, for instance. So, and for the simplicity, yes, we want to group the APIs. So, for instance, of course, the DPDK APIs, well, the naming conventions were designed where it has RTE and then the group, the ring and buff or whatever. But we want to make sure that more in the Go we wanted to wrap that and make sure that those clearly defined say that the methods are for those type, and you can't possibly call that wrong method for different type. So, very similar to the object-oriented language, but the Go is not quite object-oriented. So, but they couldn't do a similar thing. So when we create the ring, everything after that, the free or the enqueue, we define those as a method to the ring. So the caller won't get confused on these. And for the performance, we definitely wanted to avoid the memory copy where possible. So for instance, when we want to get the if header, we create the slice directly from the C memory. So you don't do the memory copy when you access to the mbuf. Of course, if you modify that slice, your mbuf would get modified, and good for the performance. You don't have to copy it back and forth there. The biggest problem here, though, is that the memory management in the Go world and C world, although they can interact with each other, they live in a different world. So the memory allocated in Go reside in the Go, and you can't, it's just live in a Go. So whatever they do in the C, the Go won't know anything about it. So, and Go also doesn't know what's going on in the C. So if you allocate the memory in C, you are responsible to release the memory in the C explicitly. So you can't automatically release when they don't have like a D in it. In some other languages they have. So you are responsible to release all the unused memory. So this is it. Yeah, there's no destructor in Go. So whatever you allocate in C, you have the full responsibility, and you must call it call C free or whatever. And also, this is one of the glitches I've seen in the Go. So the Go type, the C type you define in the package, although they have, like I say, struct RTE ring, you definitely know that there's a ring, the DPDK ring. But once you start using this in the other package and want to refer this, it's not the same anymore from the Go perspective. They don't know whether these two pointers have the same underlying C struct. So unfortunately, if when you create the DPDK, create the ring and you want to cast or the type convert to struct RTE ring, you want to be able to, and you have to go to void star, the type of the unsafe pointer thing. So unsafe pointer in Go is a void star, and so here you lose the type safeness. Okay. Well, I think we're running time here. So the materials is on the web, so I think everyone can take a look. But the one final thing is that although you have the C struct and you say this type is the C type, but the Go, unless you have the name starting with a capital letter, the upper character, you won't be able to make it visible to the package outside your package. It's not exported. So you can't possibly access to the struct. So you need a getter or setter if you want to let them to access. So, but anyway, we could kind of make it Go DPDK API Go friendly. They managed to get the type safeness. And the memory management though and type conversion requires the extra care, which still needs some more extra effort. And because we have to use a lot of them safe internally because of this. I want to, we'd like to fix this problem in the future, but right now this is inevitable for now. So anyway, I think it's a time. And those of you who are interested in Go and C bridges, there is a links. And if you have any questions, please. Sure. Oops. Oh. Yeah, there you go.
Is there a reason why you didn't integrate into NetPolar?
I beg your pardon?
Is there a reason why you didn't integrate directly into the NetPolar, into the service point for networking in Go?
So we felt it might be useful that creating a separate package might be making it useful so that we can use it later on a different project. And so we first decided to split, not directly, but sorry, I may not be answering the question properly.
No, what I see is more of a split control and data plane model where the data plane, the fast path is in C and using DPDK, and Go is using, sort of a message-based control plane interface, which you've integrated, and so they're almost two separate islands. I don't actually see DPDK integrated into Go.
Yeah, so we also discussed about that, but we also had a discussion where we wanted to make some module that doesn't require the performance, could be written in the Go, where that could be partly useful. That's had a discussion we had, and it's kind of experimental right now, but I think we kind of got the good result on this.
Can you maybe add a few details about Lagopus and Lagopus 2? Is the Lagopus 2 code already available in Lagopus? What is the difference between Lagopus and other software switches, maybe?
So yes, the Lagopus is already available, 2 as well. Although the Lagopus 2 is still the kind of alpha or the preliminary release, which doesn't have all the feature I talked today. But yeah, if you go to Go, there's a GitHub, the Lagopus VSW, you have the access to code. And 2 as well. So we were rewriting this 2, Lagopus 2 still, and I don't know what the next release is going to be, but if you have any, if you're interested in, please let me know.
Okay, and what's like the difference versus other software switches?
Beg your pardon?
The difference, what's differentiating Lagopus versus other software switches?
So the Lagopus, Interesting question. That's so. It's a full open flow. We want to make it the portable. For the Lagopus 2, still we are trying to address the where we are. That's the question my colleague can answer right now. So maybe we can talk this in other occasion. But yeah, please.
Yes, you said that there is a certain difference between the performance of the Lagopus and the Lagopus 2 because of the C and the Go differences. So what kind of difference are we talking about, like twice or 10% or?
We haven't done full benchmark yet. We are preparing this to take the benchmark. But the Lagopus 2 has more features than the Lagopus. The Lagopus is just the OpenFlow switch, and with the OpenFlow, with the Lagopus 2, we want to have more feature built in. But the performance, I don't know. We haven't done that measurement that much yet, and so once we take this benchmark, we definitely, I think, going to present as numbers.
Okay, thank you very much.
All right, thank you.